travel. Is it possible? The reason I say that is I've been researching physics, and it seems the top dog is what is that? AE, Albert Einstein. AE, not AI. Could be AI, but it's AE, Albert Einstein. Why is it Albert Einstein? Because he wrote a fictitious book in 1905 about being able to travel at the speed of light. His problem, the problem with that theory is he made that theory a reality in 1915. He made certain predictions that he said are true. They call it predictions that were found out later not to be true. But in essence, that's called AI, or adult intelligence and discovering new technology, let's say. Like the internet, that boom bang. I don't want to go further into the internet. But anyways, his problem with time. In his theory, he made a theory about gravity and mass. That when traveling, his limit was the speed of light. But when traveling at the velocity, gravity slows you down. You can't overcome what's already there, which means that the Earth's core, the Earth itself, is a mass. And a moving mass, a little one, like a ship or an airplane, gains mass as you travel. And when you hit the speed of light, or close to the speed of light, your mass is half, 93,000 miles a second. He did not discover his mistake. This is a historical mistake. He showed that mass increased and you could only go half that at the speed of light. I think it was later, could have been maybe 10 years later, 5 years later, when he introduced E equals mc squared. He introduced the idea that a vessel traveling through a gravity field like Earth, which is attraction, which I have some debate about, I'll say it easily, same masses repel. So a moving mass is a mass, the Earth is a mass, they should repel, they should attract, they should push away. Does this allow something to move? I have another theory on that. If you look at my couple earlier videos, you'll find out how the universe works. But let's go back to infinite mass. Infinite mass is c, which is the speed of light. You can't go faster than that in his theory. Fine. If you get close to that in a gravity field like Earth, you gain mass. Mass means you gain weight. You gain weight and it slows you down. That's what gravity does. It slows you down. Now, Isaac Newton measured the predicament, or if you might say, of 9.8 meters a second. He predicted and measured the actual behavior of this gravity. And its effects per second in his theory per meter. But anyways, per meter per second. Anyways, so we go back to infinite mass. So you can only go 93 miles a second. That's not true. You have a jet, incredible jet, that's able to travel at the speed of light, almost. And mass interferes due to gravity and attraction. And it slows the ship down. It gains mass. It gains weight. And it doesn't go as fast. Einstein didn't change the time equation in that statement, that claim of relativity. He stated that it changed, but he didn't change the numbers in the time sequence. 93 miles a second, no. If it slowed down and it gains weight, when it hits potential velocity, which is close to the speed of light, it travels slower. But Einstein didn't tell us how much slower or whether it's slower at all. He went with not slower at all, and he invented what's called time travel. He took that confusion about changing everything in the equation, which he didn't do. He only specified on the mass per velocity, but not the time. So what happens to time? If you're traveling 0 to the speed of light and you're traveling slower and you only go half the speed, it takes twice as long. So instead of taking 1 second, it takes 2 seconds. And this will tell you about something about light. Light's mass is predictable. It's half of whatever the quanta weight is. It's only half, which means it gains mass. That's the speed of light. I don't know whether Einstein put that in his theory, but it sounds convenient. If anything can travel at the speed of light, which is light, and it's affected by gravity, and it slows down, that it's going to take twice as long. So it's not 93 miles a second, it's 93 miles 2 seconds. Very good. That's Earth gravity. But what is Earth gravity? Is it attraction? Similar masses repel. In other words, if you have a round ball, foot round, right? And you have another ball that's only 1 inch round, which has most mass. The bigger one does, correct? Einstein left all this out of his equation. We're not using it for the weight content so much because he took his theory in the predicament of not changing the time sequence in his equations relative to light traveling at the speed of light and only able to travel half that velocity. He also left out the idea that they were similar masses. Similar masses. That means if the big ball, which is 1 foot round, was to go into acceleration, it would gain twice as much mass. Twice as much mass means it will slow down half its velocity, whatever that velocity is, compared to the 1 inch round ball, whose mass is small and traveling close to the speed of light or any velocity, it gains mass. And again, it can only travel half that velocity. per second, per hour, whatever it might be. But the energy between the two, like planets, are similar. That's why. That's one of the reasons why the Earth and all the planets orbiting the sun don't fall into it. They're similar. They can't. They're like positive and positive poles of a magnet. You put them together, they repel. They they can't join unless they're forced, which would take a lot of mass. But anyways, and there's no mass in space. And that's another thing. If there's no mass in space existing in that dark stuff, then it's empty. And part of it is that similar masses don't attract. So what's that do to our theory on gravity? 1G. It's 1G. That's what it is. That's what we say it is. The warp sequence is one. Is it 1,000 or 10,000? I have to look at my book. I think it's 10,000 though. That means that if you're going 1 mile an hour on Earth, the Earth is going 1 mile an hour. That in space, it's going to go to 10,000 miles an hour. And that's how we measure how fast planets orbit around our sun. And they don't fall into it. That's one theory. I think Newton relied on that, and he measured the distance between these two masses relative to their mass, size. But he didn't call it size, he called it mass. I think he called it mass. But anyways, Einstein never could put the time relative to the components of E equals mc squared. So he said, well, you time travel, dude. Go into the future and the past. That's what he did with that little time mistake. He left something out. And he knew it, but he couldn't finger it. He couldn't put his finger. So he took space and time and put them together. So time reluctantly is space-time is kind of hard to explain. It's the idea that whatever the distance between point A and point B is time relative to space. I have arguments against space-time. But gravity in its theory doesn't work. Gravity in his theory relative to masses don't attract. Because they repel, it allows us to move. They repel, a moving object can move. If not, we'd be stuck to the ground because a positive and a negative cling together. But they're not. They're both positive energies. That's point 2 of relativity. Check. The theory on space is pressure. Pressure relative to the expansion theory. How fast the universe is expanding relative to the force behind that expansion and the way it pushes and puts pressure on space. How does it put pressure on space? We have the Hubble rate. 42 miles a second every 300 million miles of area in a 3D dimension. Is a far-fetched way of putting it, but that's kind of like uh, you put a balloon in the middle of the universe and it's getting bigger and bigger, and the effects match his description. And since Hubble, nobody's expanded except me. I wrote over 10 books due to the expansion, due to what I'm calling about gravity. Now, I'm not trying to change gravity, but according to advanced physics, unrelative to relativity, same masses repel. They call it attraction. So you make your own opinion about it. Space is a repulse force. There's no any attraction to anything that moves in space, which elevates the velocity of the 9 planets trapped in this, with the sun to go into thousands and million miles an hour around the sun. They would probably travel faster if the sun was bigger, slower if it was smaller. But our solar system is what it is. We live in that solar system, and we are part of that solar system. And as far as our AI, our adult intelligence, when we reach a point where we start contradicting our own ideas of what we learned about our planet, we reject the planet, saying, well, that's this planet. I'm not from this planet because you got it all wrong. You know, it kind of pushes you away. It makes you a dark sheep, black sheep in a white family, or a white sheep in a black family, whatever. Could be the same. But space pushes you, allows you to go as fast as you want. And it doesn't push you to a point to where it pushes. It actually does. It's an assist project. It's an assist effect relative to your velocity. On Earth, you go half the velocity relative to your mass. In other words, if you go 50 miles an hour, it takes 100 miles an hour of force. In space, it's just the opposite, in the opposite direction. If you go 50,000 miles an hour, you need, no, if you are going 100,000 miles an hour, you only need 50,000 miles of force. It doubles. It's doubled relative to your mass that isn't there, relative to Earth's gravity that it is there. But the idea is it there at all? This is where the confusion comes in. Space is one thing, it's relative to Earth's atmosphere. But there must be another part that makes it work. Maybe there isn't. They say we are caught in the Earth's atmosphere. We move. That could be a repulse force, meaning that same masses, you walking and you connected to the Earth's ground, are able to because of the repulse force. The other thing is space is dormant. That means it's subtle. It doesn't move. It's nothing. It's what it is in the room. The Earth is expanding. This expansion is what makes everything move. And it's not the weight of the galaxies that make them uh, hug against or cushion against the Hubble Sphere, which is the Hubble balloon. There's an actual entity in the center of our universe that's making everything work. And we can only see it relative to what it does, the effects that it progresses to us. But to some scientists, they know what it is, what the element is, how it works, where it gets its energy, and why it expands. All this is in my next book, coming out, ebook. Not sure of the title it's going to be, but I got it. Anyways, so as this thing pushes against the space, it makes it move, puts pressure against it. Everything that exists in within hand's reach. If you read some of my earlier videos, I can tell you what that is. I don't want to repeat myself too many times. When we go back to Einstein's idea about gravity, he took that same gravity and directed it into space relative to mass. His theory is unique, but the picture isn't complete. The idea that attraction, that means that one would have to be positive and one negative for there to be attraction. But it's not. They're both positive. They're positive because they're energy. They're actual. They're in the fragment. They're in they're weaved into the mass of whatever object we're talking about. And as human beings, we are objects. We're not just a rock sitting there. We have mobility. The birds have mobility. There's a reason for them to have mobility. There's nothing. That's why they take gold and they make things and they hollow it out and then bend it. Even at the molecular level, they put something in there that somehow they take it out and it makes it hollow. Got that from the birds. The bones of the birds are hollow. Our bones are fragmented. They're not hollow. They're not hollow. They have something in it, but they're lighter. That's why they break, fragile. But to anything, we have two problems here. One is the attraction force relative to the energies at state, which are both positive because they relate to the same thing. And then the other one is Einstein left out. He didn't change one component. If there's two components, we have speed, velocity, and mass, and we have time. He left out time. And I don't think he could figure out that he left out time. So he said, we can time travel, and I'll tell you how. How can we time travel, Mr. Einstein? Well, when you go that speed, you can time travel. In a teeny little ship. I don't know where you get all that speed, velocity, and speed of light. That's small. It's only relative to the planets and their velocities, which is speed of light is even more, right, relative to their mass and size. Anyways, my name is Rod Kowicki. I hope you like my video. And this is just a my own opinion. Thank you. What's wrong with Albert Einstein's theory on the speed of light? An easy explanation is light doesn't change into lead. All objects have what's called mass, according to relativity, energy. That energy is affected by gravity. Okay, it's affected by gravity, and it changes as velocity increases. But does it change into lead? We're talking about light, quanta particles that have almost a zero mass. They do have some kind of mass. They're made of reality, you know. So they do have some sort of mass. We could see them. Now, you push that light, it changes into a light beam. You raise its quantity, but it doesn't change into lead. So, what's wrong with relativity?